Hi guys! This is a review of piecewise functions. We talked a little bit about these, I think it was in chapter 2. I want to go over them again because it is really important that you know how to do these. Hopefully these notes will help you understand it a little bit better, but you certainly want to be able to do this at least this semester on your final exam. Okay, so first of all, you're given a function and it's in two parts. It's not like just one rule that you have to follow. So here I have two rules, but I have information telling me when I can use each of these rules. So I can only use this if the value for x is less than -2. And I can only use this rule if the value for x is greater than or equal to -2. So the first thing that we want to do is go through and let's see if we can just evaluate if we're given information. So this says find f at -5. Well, I look over here and I say, okay, which one of these satisfies -5? So my x value, is it less than -2 or is it greater than or equal to -2? Well, -5 is less than -2, so I get to use this rule up here. So I say, okay, in that case, f at -5 equals, I put in my -5 for x, -5 squared minus 1. So f at -5 equals 25 minus 1. F at -5 equals 24. If I wanted to graph this, I would go to the x value -5 on my coordinate plane, and then I would go up until I got to 24 on the y-axis. Okay? All right. So let's find the value of f at -2. Well, f at -2. If I look here, it says x is less than, it does not have the equal to -2. Okay? This one does have equal to -2, and since my value is equal to -2, I have to use this row. Okay, this is the rule to follow. So f at -2 equals 5 times -2 plus 3. So f at -2 equals -10 plus 3. F at -2 equals -7. Again, if I wanted to graph this, I'd go over to -2 on the x-axis, down to -7 on the y-axis. Okay, and then evaluate f at 7. Well, f at 7 is greater than -2, so I use this bottom row. So I say f at 7 equals 5 times 7 plus 3. F at 7 equals 35 plus 3. So f at 7 equals 38. Okay, so first of all, you need to know how to do that. Once you can do this, then you can graph it. Okay, now let's say that you have more than just the two parts here. Now you have three parts. Okay, so now you're doing the same thing. You just have to figure out, again, out of the three choices, where does your value fall? So g at 2, well, is 2 less than or equal to -4? No. Is 2 between -4 and 1? No. Is 2 greater than or equal to 1? Yes. So we're going to use this section here, and we say g at 2 equals 2 times the x value that I'm using is 2 cubed plus 9. So g at 2 equals, don't forget to do your exponents first. You cannot multiply this first. Okay, so we get 2 cubed, which is 8. 2 times 8 plus 9. So we have g at 2 equals 16 plus 9. G at 2 equals 25. So if I were to graph this point, I'd go over to 2 on the x-axis, and I'd go up to 25. At -1, so we say, okay, does -1 fit here? Is -1 less than or equal to -4? No. Is -1 between -4 and +1? Yes. So I'm going to use this row right here. Be careful with this one because it starts out with a negative x. So we have negative. The x value that I'm using is negative 1, and then minus 1. So a negative value, or the opposite of negative 1, is positive 1. So they cancel each other out. So 1 minus 1, g at negative 1 equals 0. So if I were graphing this, x of negative 1, so I go over x equals negative 1, and I stay there. So I'm right on the x-axis. All right, and now if I have a negative 6, well, is negative 6 less than or equal to negative 4? Yes, it is less than. So g at negative 6 gets to use this, so we say equals half of negative 6 plus 3. So g at negative 6 equals negative 3, because half of negative 6 is negative 3, plus 3. G at negative 6 equals 0. So if I go over to negative 6, I am at 0 there. Okay? All right. So now let's work on how to graph it, and then we'll talk about domain and range. Okay, so for number 3, now it's not giving me any values to plug in. I get to choose what values I want to plug in, and really what I want to do is I want to plug in some that work here, and I want to plug in some that work here, so I can see both sides, both pieces of this function. Okay, so what I'm going to do is I'm going to take a separate sheet of paper, because I don't want to make it all messy here. And if you want to, if it helps you, you can take a look at a number line and say, okay, negative 3 is the value that they're really looking at, negative 3. All right, so I need some values that are less than negative 3. So negative 4, negative 5, negative 6. This helps you to see it on the number line. So at negative 3 or equal to, I can use this information here. Okay, so let's see what happens when x is negative 3. Well, if I just plug in negative 3 here, so f at negative 3 equals, well, negative 3. So that point would go at negative 3, 1, 2, 3, negative 3, 1, 2, 3. And I do close in that dot there because I can actually use negative 3. It is equal to there. That's why I chose negative 3. Now, let's see what happens at negative 4. So f at negative 4, well, f at negative 4 is you just plug it in, so it's still negative 4. Okay, so at negative 4, I go negative 4. What do you think would happen at negative 5? Be at negative 5. So negative 5, negative 5, negative 6, negative 6, negative 7, negative 7, and so on. So that's this part. I should use a ruler. This is this section. Now, for this section here, I cannot use negative 3, but I can use all of the values that are really, really, really close to negative 3. So what you do here is you still want to plug in negative 3 to see what happens, but you're not going to be able to say, I can actually land there. I can be on that point because it can't be equal to it. Okay, so let's look at, let's see, this would be negative 2, negative 1, 0, and so on. All right, so at negative 3, if I were to plug it in there, f at negative 3 equals, well, negative 2 times the negative 3, because that's the x value, plus 1. F at negative 3 equals 6 plus 1. F at negative 3 equals 7. F at negative 3 equals 7. So at negative 3, I am at 7. 1, 2, 3, 4, 5, 6, 7. Now, because there is no equal to, when I plug in negative 3, I have to put an open dot here to say, you know, I'm going to get really, really close to that value, but I can't land on negative 3. Okay, so let's see what happens at negative 2. So f at negative 2 equals negative 2 times negative 2 plus 1. 4 plus 1, so f at negative 2 is 5. So at negative 2, it's at 5. Negative 2, I'm at 5. 1, 2, 3, 4, 5. Okay, I'm just going to put a little dot there. What happens at negative 1? F at negative 1, the equation was 2 times the x value plus 1. Okay, so f at negative 1 equals negative 2 plus 1. Negative 1. Oh, I'm sorry, I didn't plug it in correctly. This is negative 2 times 1, so positive 2, which is 3. Okay, so at negative 1, I'm at 3. At negative 1, I'm at 3. 1, 2, 3. You see a pattern that's happening? Okay, at 0, if I were to plug in 0 here and have negative 2 times 0, just 0, plus 1. So if I plug in 0, I'm at 1. And this keeps going forever and ever. And again, I should use a ruler. Okay, it keeps going on forever and ever, that direction. So let's talk about the domain and the range. The domain is the x values. What x values can be used? Well, you notice that this arrow keeps going. As it travels downward, it keeps widening to the left. It keeps expanding that way. Okay, so if you can keep doing that forever and ever and ever, that means I can go all the way to negative infinity, right? All right, and then as I come back up, travel here, I am at negative 3. Negative 3 is usable just on this part of the graph. So in this section, we use negative 3, and in this section, we don't. But negative 3 is used if you look overall at the graph. Negative 3, okay, and then I have to jump up here, and I can use all of these values, and notice it keeps going forever and ever and ever and ever and ever this way, and notice it keeps widening out. It's going down at an angle, it's not going straight down. So it's going to keep getting wider and wider. So I'm going to go all the way to positive infinity. Okay? So all of the values are used. You can either write all real numbers here, or you can write from negative infinity to infinity. Okay? Now, the range values, the range is the y values, okay? And you have to be careful here because you want to look at what are all the usable y values. Well, because this arrow keeps going down, 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 it's going lower and lower and lower. So it's going to keep going to negative infinity. This one also goes down, 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 down. So negative infinity is where the lowest is going to start, negative infinity, and then look at your graph and say, okay, is there a point where it stops, the graph no longer reaches, it doesn't go above this point? So hopefully you've noticed that this is the highest point. There is no arrow going up or saying that, hey, we keep going further, further upward. So since that does not exist, then this is the highest point. So that's the most that we can use. And that is at 7. 1, 2, 3, 4, 5, 6, 7. And be very careful. That value is not a closed-in circle. It is not being used. It's not a definite place to land on. So we're going to leave this as a parentheses instead of a bracket. Okay, you try the rest on this sheet, and if you have any problems, we'll talk about it in class when I return.